जय श्री राम दोस्तों, welcome you all a new topic that is unleashing the power of instruction set, a journey into the microcontroller and embedded system. In this video, we will learn about several topics like firstly we have the introduction part, secondly we have the what is instruction sets, after the types of instruction set achievement, programming language, instruction set design, optimizing instruction sets, real world example and conclusion. Welcome you all in the introduction part. Welcome to the fascinating world of microcontroller and embedded system. At the heart of these technologies lies the concept of instruction set, the fundamental building blocks that enable these devices to perform complex tasks with a remarkable efficiency. Whether you are a seasonal engineer or are just starting out, understanding the instruction set is essential for unblocking the full potential of these powerful tools. This is the presentation will explore everything you need to know about the instruction set from the basic how to they work to the different types of architecture available to design and optimizing techniques used to create them. Along the way, we are examining real-world example of the instruction set are used in practice and discuss the exciting possibilities for future innovation in the field. Next, we have what is instruction set. An instruction set is a collection of instructions that is process can execute. These instructions are basic building blocks of a software and they determine how to program with run on a given processor is essential for instruction set defined as a vocabulary of a processor. Instruction sets are crucial in microcomputer system and embedded system because they determine the capability of these devices. By carefully designing instruction set, engineer can optimize performance, reduce power consumption and improve reliability. In an additional instruction set can be tied to a specific application, allowing for a greater flexibility and customization. Nextly, we have the types of instruction set. Instruction sets are crucial part of embedded systems and microcomputers. And there are two main types: complex instruction set computing, reduced instruction set computing. Instruction sets have a large number of complex instructions that can perform multitask, while RISC instruction sets have a small set of simple instructions that execute quickly. This processor require more memory and power, but can handle more compatibility operations. On the other hand, these processors are simply and in other hand, these processors are simpler and more energy efficient, but may require more instructions to accomplish the same task. An example of such instruction set is the Intel 86 architecture, which is used in many desktop and laptop computers. In contrast, the ARM architecture is an example of RISC instruction set, commonly found in mobile devices and embedded systems. While both architectures have advantages and disadvantages, the choice between the ultimately depends on our specific requirements on applications. Nextly, we have the instruction set architecture. Instruction set architectures, that is ISA, refers to set of instructions that is microcontroller embedded system can execute. It defines the operation that can perform, the data type can be used, and a format of instructions themselves. The ISA is a crucial aspect of a microcontroller embedded system design as a determine the compatibility and limitation of a system. Designers must carefully consider the ISA which selecting a processor for a particular application as well as the designing custom instruction sets. Nextly, we have the programming language. Programming language play a crucial role in writing instruction and microcontroller and embedded system. These languages are used to create the program that control the behavior of these devices, enable them to perform specific tasks. Some of most commonly used programming language in context of C, C++, Assemble, and Python. Each language has a strength and weakness, and the choice of a language depend on factors such as compatibility of a task, the performance requirement, and availability resources. C is most choice for a microcontroller programming due to level access of a hardware and efficient memory. C++ is an extension of C and add object-oriented programming features makes this suitable for large and more complex projects. Assemble the language provide directly control over the process and it uses when maximum performance is required. Python is high-level language that can easy to learn and use, making an idea for rapid prototype and development. Nextly, we have the instruction set design. Instruction set design is complex process that involve carefully considering of a various factors. One of the key challenges is balancing performance with a power consumption. This requires designer to carefully select and optimizing instruction to ensure that they are both efficient and effective. Another important condition is size of an instruction set. While large instruction sets can provide more functionality, they also require more memory and can slow down the system. Designers must therefore seek the balance between the fundamentals and efficient when designing instruction sets. Next, we have optimizing instruction set. Instruction sets are crucial component of microcontroller and embedded system design. To optimizing instruction set, designers must consider a range of factors including performance, power consumption, and cost. One technique for optimizing instruction set is used to pipeline which allows the multiple instructions to execute simultaneously. Another approach is the parallel processing, which can significantly improving performance in certain applications. Other optimizing site techniques include reducing the number of instructions required to perform a task using the specific instruction for a common task and minimizing the use of memory by carefully designing and optimizing instruction set. Designer can create a microcontroller and embedded system that can faster, more efficient, and more cost effective. Next slide, we have a real world example. One of the example instruction set are used to microcontrol an embedded system is this field. The robotics robot often the required precise and efficient control to perform the tasks such as assemble line work on surgical process. By optimizing the instruction set for these specific application, engineers can ensure the robots operating smoothly and accurately. Another example is development of a smart homes and Internet of Things devices. These systems rely on a microcontroller and control various functions such as temperature and lighting. By designing instruction set that can optimizing for a long power consumption, developers can create devices that are energy efficient, have the longer battery life. Lastly, we have the conclusion part of this video. In conclusion, we have explored the world of instruction set in microcontroller and embedded system. We have learned about the different types of instruction set, the concept of instruction set architecture, programming language used to write instructions, and the process of designing and optimizing instruction set for specific application. It is clear that instruction sets play a crucial role in our performance, power consumptions, and overall functionality of a microcontroller and embedded system. As technology continue to advance, it will be interesting to see how instruction set design involves the meet of demand of new applications and use cases. We encourage you to continue exploring the fascinating field and stay up to date on our latest development. Thank you for joining us in this journey through the world of instruction set. Thank you. This is Manoj Kumar, 1B21CS 095.